Okay, we're here with Paul Larson. Paul, tell me a little bit about your background and what you do at MSR, Microsoft Research.
All right, let's see now, how far back should I start?
Well, as far as relevant.
I finished my studies in Finland, and then I came to Canada as a visitor for 1 year. After 3 months, they decided they wanted to make me a permanent faculty member at the University of Waterloo. So I accepted, stayed there for 15 years. And then in '96, I joined the database group here in Microsoft Research. And I've been here ever since, working on various aspects of database systems, which I've actually done since early 1980s.
And you're famous for inventing a linear hashing algorithm. Tell me a bit about that. What is that for someone who may not know?
It's a hash table that as you add elements to it, it automatically grows, and the lookup times and so on stay stable.
And can you tell me, how have databases changed throughout the years that you've been at Microsoft Research?
Surprisingly little, surprisingly little. The basic architecture of most relational database system goes back to early 80s. And yes, things have been added, and they've added functionality and so on, but the basic underlying architecture has not changed, still the same.
And several years ago, you collaborated with the SQL team to create some new technology called Hekaton. What was the motivation for this?
Well, the motivation was that the underlying hardware platform had changed a lot over the last 30 years since the basic architecture of SQL Server was designed. It had changed to the point where it was clear that we couldn't stay with the old architecture and hope that that would survive for another 20 years. We had to respond to, among other things, very large main memories and lots of cores.
And describe what is Hekaton and what makes it significantly different?
So Hekaton itself is a main memory database engine. So it assumes that the tables that it manages are stored entirely in memory. And given that there are lots of things that you can simplify compared with current database systems. So we removed a lot of the overhead that you have in a traditional database system. We invented a lot of new algorithms and so on to make use of the fact, to be able to exploit the fact that these are in memory, and to be able to scale them to very, very large number of processes. I mean, we need to scale to hundreds of processors.
And typically when people think of scaling something, they want to throw hardware at the problem. At what point does more hardware not benefit and lead you to redesign how databases are built?
You have throwing hardware at a problem where you have inherent, where the limitation is inherent contention, doesn't help. So I'll give you an example. Database systems have something called a lock manager. So every time you need to look at a record, you first have to get a lock on it. And that means that you have to go to a shared data structure. This shared data structure has to be protected because there's a lot of concurrent activity on it. And that locking and protection of that lock manager itself now becomes a bottleneck. You can only have so much concurrent activity on it, and that ends up limiting the throughput that you can get. So it has nothing to do with hardware. It doesn't matter how many cores you throw at it, you're still limited by that. You have some inherent bottlenecks in the software. So not much you can do. You can throw hardware at it, but it won't help.
And so Hekaton is based in memory rather than on disk?
Yes, it's entirely, the data is stored entirely in memory, and it has a number of other innovative features. One thing, for example, is that all data structures are lock-free or latch-free, which is the best technique that we know of to support very high concurrent access on data structures.
And how do you handle fault tolerance on servers with a database that's entirely in memory?
Two ways. All updates are still logged to persistent storage, whether it be disk or solid state disks and so Hekaton is fully integrated into SQL Server, and SQL Server has a high availability feature. Basically, you have replicas of the database on other machines. And on a failure of the primary, the secondary takes over within seconds. So Hekaton is fully integrated with that.
And so tell me about the collaboration with the SQL team. How did that come about?
Came about because I had been working with them on something else, which is also in the product. And then they started thinking about, well, so what can we do for transactional workloads? Can we get something that would go really, really fast for transactional workloads? That project started and I got involved with it right away. So I've been working with SQL Server for a long, long time.
And how did the collaboration come about?
I think it started pretty much because we were working together some on the column store.
On the column store, yes.
And
well, at the
Paul
time,
was-
Mike was leading sort of an advanced development effort.
That's right.
And that group, that was a small group, decided to start looking at what can we do for OLTP
Mm-hmm.
with these new architectures coming in, and what do we need, and set very ambitious goals.
And,
Yeah.
and what was it with SQL that just couldn't move forward, that you had to change?
Well, it's not just SQL Server. It's kind of disk optimized database systems in general share this property. So I like to be clear that it's not SQL Server is slow. It's that SQL Server is optimized for a different set of hardware capabilities. And so it's what it's optimized for and what it's targeted at. And also, I guess the other trend that was happening, and Paul was instrumental on that also with the column store technology, is building specialized engines that are optimized for particular workloads. And column stores are optimized for business intelligence and data warehousing workloads. And in talking to Paul early on, okay, what could we do that would optimize for OLTP workloads? And that mindset that it's okay to optimize different engines for different workloads and incorporate them into one product was kind of a key.
What are the types of scenarios that Hekaton shines and excels?
It excels at random lookups of data. It excels in workloads that need very low latency, sub-millisecond, measured in hundreds of microseconds, or even less latency to get to look up rows and to look up data in tables.
High contention scenarios.
High contention scenarios when there's lots of transactions fighting over a small set of data or data that's frequently updated and frequently accessed together while it's being updated. Those are kind of coarse descriptions. If you look at workloads, you think of workloads that do this. Online gaming, shopping cart maintenance for websites, stock trading, inventory, real-time inventory analysis, so that you can be analyzing your inventory while it's being rapidly changed. Those are some of those. Ingestion of
Very fast ingestion
fast
of data.
ingestion of data that might be bursty. A big lump of data is coming in. Be able to absorb it quickly, get it indexed instantly and available for access.
And so going into the project, what were your aspirations as far as increasing speed, and what were the results?
Well, the aspirations, actually originally we were thinking, well, maybe we can get 10x. But we talked to Paul and others who really challenged us to think 100 times faster, thus the name Hekaton. And the focus there was about, if you think 100 times, you basically have to rethink everything. Anything in the path of execution that the database system is doing is a potential bottleneck at 100 times. So that was the aspiration, force us to rethink everything. We would have been perfectly happy with 10, right? That's great. But not settling for that initially was actually a really important.
It was important
to change our mindset.
because it forced us to rethink. We couldn't basically reach into the tool bag and say, well, what's the old solution that we have for this? We tweak it a little bit. No, we had to rethink everything.
Right.
And everything really is rethought in Hekaton.
What were some of your biggest challenges that you had with this project?
Oh,
You want to
geez.
start?
There's plenty of them. One thing that I was heavily involved in, so I'll bring that up, was how are you going to make sure that you can have highly concurrent access to data without much overhead?
Right.
Traditional techniques for main memory database system just had too much overhead, so we had to rethink that, which we did. So that was challenging.
I think another area was fairly early on in the project, we developed the core techniques that would get us 40, 50x. It was the integration into SQL Server that was really hard for a variety of reasons. One is that SQL Server is a large, complex product itself, and to introduce a new engine inside of it and to incorporate how it works with the way SQL Server works was a big challenge. And the other area is it's a mission critical product. People use it for their mission critical systems, and so the quality, the reliability, all that has to be there, and it has to be there in V1. It can't be there later because the applications that want to use this high performance technology are also usually mission critical applications, and so really achieving that the quality bar that SQL Server sets was one of the harder pieces too.
That was an incredible amount of work that the development team has done. I mean, that's huge.
And so, what did you and your side of the team bring to the table? What parts were you working on?
Well, I worked a lot on the concurrency control and the data structures and that part of it. That really sort of core storage engine. That's primarily where I've been focused.
Mm-hmm.
And were you working with customer partners? Were you able to get feedback from people who are actually using this?
Yeah, actually fairly early on in the project, we started looking, working with customers early on to get their feedback on our ideas and then to give them very early versions of the code to try out and play with and see what they could achieve with it, get their early feedback.
And what types of gains did they see from the beginning?
Well, one customer that tried it very, very early on went from 15,000 transactions per second up to 250,000.
250 now. I think initially they saw 150,000, so about 10x.
10x
now
right
they're
away.
About 20. So generally, the feedback was yes, it can help us go fast, but we want more features. That was the feedback that's been consistent. We're listening to that and trying to add, to broaden its feature set as much as we can. So.
Right.
And is that what's next? Is that what you're going to be working on next?
That certainly is a key piece of it. Broadening the feature set, giving this performance capabilities to a wider set of applications, making it easier for applications to adapt to using the memory optimized tables is really a key thing going forward.
So if someone's watching this and they're excited that they can perhaps make their database and their transactions faster, what do they need to know if this is right for their application?
Probably the key thing right off the bat is, first of all, you don't have to change your whole application. The more you can understand about where the performance problems are in your application, where the contention is, what are the most critical tables, the most critical stored procedures, that information is valuable. We have a tool that can help you analyze that as well. But the starting point is, once you kind of know the areas you need to optimize, it starts with converting one or more of your tables to being memory optimized. And the key requirement there is it must fit in memory. If it doesn't fit in memory, it's not eligible, right? And that's a key point, I think, about Hekaton.
Well, one of the really distinguishing features of Hekaton compared with competing products is that we don't insist that you put all your data in memory.
Absolutely.
You can keep your old databases, most of your tables, just using disk-based table, and you take the most performance critical ones and convert those.
Right.
So it's not an all or nothing solution. You start gradually.
Yes, that's certainly very key to it.
Right.
So how did working with a researcher impact the project that you were working on here?
I think it had a big impact. Working with Paul, I think one of the key things he brings to the table is he knows how databases have been built, the research around them, the engineering around them. We worked with him early on with the column store technology,
Right.
and one of the core things he did was help us understand how to incorporate it into SQL Server. And the ability to take a new engine like the column store engine and incorporate it into SQL Server
Right.
was kind of a critical experience for Hekaton, because we needed to do the same for it. Also, you have early experience in hash indexing technology,
Indeed.
linear hashing technology.
Yes.
Hashing technology is one of the key indexing concepts that Hekaton has. And probably related to it is even the ability to publish the work that we did jointly. You have so much more experience than the development team, and in publishing it and getting the word out there about what we've done. We've collaborated on two papers for Hekaton.
for Hekaton,
So that's been very valuable as well.
Well, I should know by now. I've been doing it for what, 35 years.
Where can people go to find out more about this incredible work that you've done, or if they want to try it for themselves?
Well, Paul, you want to say you can
Yeah,
find
I
out about
can-
the research work?
The research work, you can go to my website. There's pointers to research papers on that and so on. And then on the product side, there's much more.
Yeah, the development team has a whole blog series, and we also have the CTP2, SQL 14 CTP2, available for download, so you can try it out. And
Right, and all the documentation is
yeah, documentation's
available.
all on there. It's all on MSDN.
So plenty of information.
And so as you move forward, what's next, and what are some of the bottlenecks that keep you from going, 200 times faster?
Oh no!
Well, we still have to get to
no.
100.
You gotta think about what 100x means. Going 100x faster is that you have to get the same work done, getting rid of 99% of the work that you tried to do.
Yeah.
So in computing terms, you get rid of 99% of the instructions and still get the work done. That is
Yeah.
very difficult.
Yeah, and 100 times, even 100 times is, it's not 60 miles an hour, it's 6,000 miles an hour.
Right.
And that's a big enough difference. But to answer your question, we basically want to unlock the 10, 20, even 50x gains for more and more applications. And that just involves optimizing some of the areas we didn't optimize. And also, the first release doesn't give you the full feature set of SQL Server when you want to use these memory optimized tables. And for most customers, it's not that they can't get, that they're not satisfied with 10x and they want us to give them 50. It's that they can't convert more of their application easily, and they'd rather have more of their application get 10x than certain small parts get 50. So we're going to go after the wider, broader applications.
Right. It's a version 1 product. Still a lot of work to do.
Yeah, that's for sure.
So while you may be referred to as a grandfather of databases, you might be a great-grandfather at some point.
I am a grandfather, but calling me a grandfather of databases, that's pushing it a little bit too much. There are lots of other people that could aspire to that title.
Thanks for talking to us today.